Finally, let's just make a couple of observations regarding AC coupling amplifiers. Coupling with a capacitor, so we remove the DC component, any DC component coming in, and how that AC coupling capacitor impacts our treatment of input bias currents. You'll recall when we were talking about the output or the offset voltages and capacitively coupled, putting that capacitor in there effectively takes R1 out of the circuit, and we're left with basically a voltage follower situation. In keeping with this idea then, well, to determine now what the value of R3 should be, in keeping with the idea that each of these inputs, each of these terminals should see the same effective resistance going out. With this capacitor in here, we've effectively removed R1, so the resistance that you see or that is seen from the inverting terminal coming out is just R2. So to have the same effective voltage or the same effective resistance from the non-inverting terminal, we want to make R3 equal R2. And of course it's being pulled to ground, so that there is a way for the current to flow through the through R3. Now, if you're putting blocking capacitors on both the inverting and the non-inverting terminals, we still need to have a pathway to ground for that input bias current to flow. See, if we're just so we make it so that the resistor R3 is still going to ground, but then tie the input through the capacitor in this form. If we just put the capacitor in here, it would remove R3 from the circuit also. So we've got to provide that path to ground with R3 for it to accomplish its purpose of being there.